A chiral center is defined as any atom bonded to 4 different substituents or groups. Once an atom has been identified as a chiral center, it may be classified as having R or S stereochemistry. Throughout this video, we will learn how to label R and S configurations by looking at skeletal structures, Newman projections, and Fisher projections. Let's take a look at the first example. The first step is to assign priority to the 4 atoms directly bonded to the chiral carbon based on their atomic mass. If this is our chiral carbon, the 4 atoms directly bonded to it are hydrogen, which weighs 1, oxygen, which weighs 16, bromine, which weighs 79, and carbon, which weighs 12. Because bromine is the heaviest, it will be assigned the number 1 priority. Oxygen is the second heaviest, then carbon, then hydrogen is the lowest priority group because it is the lightest. When assigning R and S configurations, the lowest priority group, in our case the hydrogen, must be going back, which is indicated by the dash. After looking at the lowest priority group, draw arrows between 1, 2, and 3, and look at the rotation. If it is clockwise, it is R. If it is counterclockwise, it is S. For this compound, the rotation is counterclockwise, indicating this chiral carbon has S stereochemistry. Let's look at an example where the lowest priority group is not dashed, but instead it is wedged. I've identified the chiral carbon with an asterisk. First, find the 4 atoms directly bonded to the chiral carbon and rank them based on mass. Chlorine weighs 35, hydrogen weighs 1, oxygen weighs 16, carbon weighs 12. Based on these weights, chlorine is the first priority group, oxygen is the second, carbon is the third, hydrogen is the fourth. Draw arrows to indicate rotation. In this case, the rotation is counterclockwise, indicating S configuration. But you cannot forget the third rule. The lowest priority group must be going away, and it must be dashed. In the case of Newman projections, all atoms bonded to the first carbon are wedged. The lowest priority group is wedged, which is the opposite of what is required. So take the opposite, and R is the final configuration. R and S configurations can also be identified by using Fisher projections. If this is the chiral carbon that we are looking at, identify the 4 atoms directly bonded to it: chlorine, hydrogen, carbon, oxygen. When assigned by their weights, we see chlorine once again is the first priority, followed by oxygen, then carbon, and then hydrogen. Draw directional arrows. This is counterclockwise, indicating the stereochemistry is S. Don't forget about the third rule. The lowest priority group has to be dashed. In Fisher projections, the horizontal bars are represented by wedges, and the vertical bars are represented by dashes. You can see the lowest priority group is wedged. It is not dashed. This is the opposite of what is required. Switch the configuration to R. To summarize, a chiral center is any atom bonded to 4 separate substituents. When identifying R and S, the 4th priority group must be pointed away. When arrows are drawn between the first 3 priority groups, a clockwise rotation equals R, and counterclockwise equals S.